Ladies and gentlemen, welcome to Outrageous Science. This is where we're going to explore some fun stuff. Anyway, enough with the music. We're going to get on to the program here. What I'd like to talk about today is assumptions. Because assumptions are not science or knowledge. Assumptions and theories are fiction. Until proven, they are not confirmed or settled science. The first big, fat, juicy assumption or subject that we're going to talk about here today, and it's going to be a series. It's not going to be covered all in one because it's kind of complicated. There's a lot of details. We're going to dig in kind of deep here. It's going to cover, are you ready for it? 4.5 billion lies. The Earth age fabrication. How there are so many assumptions and incorrect conclusions regarding this facet of belief. It's ridiculous. It's outrageous. And that's what we're going to talk about here on Outrageous Science. So, part one of assumptions. Oh, by the way, please, if you haven't already, click on that subscribe button and click on the all bell so that you get notifications on a new upload. Now, it's just me putting these things together. And frankly, I've got a full-time job and I'm going through a boot camp and all this kind of stuff. So I don't have a lot of time to put all these things together. So please be patient. But when they come out, they're going to be good, or as good as I can with the massive budget that I don't have. Here we go. This is the periodic table of elements. And this is my nice green pointer mouse. So you got the helium over here, hydrogen on this side. The noble gases over here, the noble things that don't like to associate, and these other, on the left side, they like to attach to everything. But we have discovered a new element in science that's not on this periodic table at this time. You ready for it? It's BS, bad science. So, a lot of times scientists or theoreticians, if they can't dazzle you with brilliance, they baffle them with bullshit. Yes, that's what happens, unfortunately. So, how many contrary items of evidence does it take to invalidate a theory? A theory becomes obsolete when it's inadequate, incomplete, or simply a false description of reality. But unfortunately, we have a lot of forces supporting false descriptions of reality just because it's got a lot of weight behind it. There are agendas and money and bias, all sorts of things contributing to why theories are sustained when they should collapse and disappear, put on the scrap heap or the compost pile of history. So assumptions are not science. We already talked about that. But what does it take to know something, to be aware of through observation, inquiry, or information, have knowledge or information concerning, or be absolutely certain or sure about something? What does it take to say, I know? So, how old is the Earth? What evidence do we need to say, I know how old the Earth is? But what the experts tell us that they know how old the Earth is, this.
Hundreds of millions of years and billions of years.
Billions and billions, billions and billions.
So we are told that the age of the Earth, is 4.54 billion years old, give or take 400 or 45,400,000 years. That's pretty precise. But what's the story behind it? There's actually some huge, big assumptions used to concoct the age of the Earth theory. But the biggest assumption is this. The sun is a 4.6 approximately billion-year-old hot, glowing ball of hydrogen and helium. That's actually an assumption based on faulty and incorrect methods, procedures, theories, assumptions, just a whole big conglomeration of assumptions. A huge assumption involved in the calculating of the age of the Earth, the age of the Sun, age of the solar system is the radiometric dating. They state that it accurately measures the age of a rock. But what it really does is measure radioactive elements in a substance, and there's lots of other assumptions surrounding that to extrapolate and concoct a theory of how old something is, how old a rock is. Another huge thing is that we'll go into in depth in another episode is that meteorites found at Barrington Crater, Meteor Crater in Arizona, are meteorites. What? Could they not be meteorites? Then why is it called Meteor Crater? What's the story behind that? It's a really, really compelling story with a lot of details, a lot of evidence, and lots of fun. I don't know what episode it's going to be, but it's not going to be in episode 1, this one. So right now, this is just going to be an introductory one, but here's a picture of an piece of iron that was found outside of Meteor Crater. Just a nice little sample that they've got there at the museum. It's a privately owned museum there, but it's a national historical monument or location. But it's privately held. Now, we're going to go into the Patterson's dating method of meteorites, but we're not going to cover that tonight. What we are going to cover is just a little bit of fun stuff. Okay? Let's look at this. This is our solar system. You see Voyager 1 way outside of our solar system. Voyager 2, Pioneer 10, or 11 and 10 over here. This is, I'm going to put the links to this fun stuff in the link, okay? Or in the description. The links will be in the description that I'm going to cover here. But this is a really nice thing that NASA, eyes on the solar system. And we're just going to zoom in all the way to our sun, and we'll do a little flyby on some of the orbital paths. You can see how Uranus is there, Neptune, New Horizons, Mars, Jupiter. It's really kind of cool. It's a nice animated, and well, you'll see here in a minute. But some of the things are right on the plane. But why is everything rotating around the sun in a fairly flat rotation pattern? But the actual direction of the solar system is going this way. So it's actually kind of a helical thing. Very interesting when you see some animation of that. But you've got the sun right here. That's the center. What? We're going into the sun. Stop. Oh, my cheap computer fan is going off, so if you hear that, that's what that is. So we're going to zoom out again, and we're going to tilt down. And we're going to see some fun little animation. Okay? So you see the elliptical Parker Solar Probe. If you're an American citizen, you helped pay for this. But if you look at this, this is really kind of cool. Now, how far? I mean, the sun is the biggest object in the solar system. But why didn't it suck in everything? You got Mercury in oblique, it's off center a little bit on its orbit. Then you got Venus, Mercury, Venus, and then the third rock from the sun. Is it really a rock? Is it just rock? Lucy. What the heck is Lucy? How did that skeleton get out there? No, just being silly. So you got Mars outside of the orbit of Earth, and then you got Jupiter. Oh, and the AC's going on. How about that? My expensive studio. There's no screening that. And then you got Saturn way out here. Then Uranus all the way out here, Neptune. And they don't even have that other non-planet out here, do they? They just eliminated it from the animation, that Pluto thing. But what is kind of cool is we're going to start the animation up here. And that's the real rate of rotation, but we're going to make it go faster. And you'll see 5 seconds per second, 30 seconds per second, 1 minute. No, let's speed it up. 3 hours per second. I mean, if you zoom it in here, you'll see it start to move a little bit. See how they're slightly moving? 18 hours per second. But it's kind of imperceptible. So let's see. Can we do 24 hours? Exactly. No. Yeah, 1 day. 1 day per second is going by. So in the inner planets, they're rotating fairly nicely. Parker Solar Probe is cruising right along. Mars. But as we go out here, Jupiter is barely moving. Saturn, barely. Uranus, can't even tell. Neptune. But let's speed it up to see how fast it'll go. Let's do 1 month per second. So you can see them really start to cook along a little bit. And then 2 months, let's do 1 year per second. Well, now that's starting to cook, it's starting to move. But let's zoom in on this. But let's start over, because we want to see these things. 1 year per second. Ooh, that was too fast. See how they're really spinning around compared to the outer planets. Anyway, I thought that was just a little fun thing. So we're going to stop that. Now, our sun, when somebody says is, what does is mean? Well, it depends on what the definition of is. You know what I mean? The sun is a 4.5 billion year old yellow dwarf star, a hot glowing ball of hydrogen and helium at the center of our solar system. It's about 93 million miles away from the Earth, and it's our solar system's only star. Without the suns, anyway. From our vantage point, blah, blah, blah. Hottest part of the sun is its core. How do they know that? 27 million degrees? I think there are some assumptions being made here. What do you think? Why I wanted to show you this is the sun is the most massive, and everything's really far apart in the solar system. But why didn't the sun suck in everything? And if it's just gas, how did it form together? Because gas is really light and it doesn't have much of a gravitational pull, but how did it situate itself in the center when it's so light, and yet it didn't suck in the heavier debris from the other planets and the asteroids and the dust and the theoretical garbage that's out there to form everything? So NASA tells us what we are to believe. But they're stating that it is a known fact where it is just theory. Now, a study shows water worlds could be as common as Earth's. So back here in the solar system, is the Earth really just a rock? Or is there more water in our solar system? I mean, haven't you seen some reports on Mars? How they found water on Mars? And on some of the outer planets, they've got some of the moons are just hydro fountains. They're volcanoes of water shooting out for hundreds of miles. Anyway, a study shows that water worlds could be as common as Earth's. What? So could our Earth be more than just a rock? Because we're told that the Earth is just a hot ball of goo right here. You know, a big old hot ball of goo there was another one. Anyway, the study shows that the water worlds could be common as Earth's. Up to 50% of the total mass of the planet can be water. Large quantities of water, which can reach up to detailed analysis here. This is the observatory group that's out on the Canary Islands where those earthquakes were going on earlier this year. It's a really, really beautiful telescope out there. But they've discovered some really cool things. You'll be able to read this article. I'll have the link in the description. But this is what we're told is going on in the sun. 27 million degrees because it's all radioactive, generated, just a radioactive explosion of hydrogen and helium. A fusion reaction going on here. And then 12 million degrees cools down a little bit. And then 4 million degrees. And then to about 10,000 degrees. And then, maybe 11,000 degrees there. And then you've got the corona, 1.8 million degrees. Wow. Pops up from 11,000 degrees to 1.8 million. It's further out. Why is that happening? It's very confusing to scientists that are supposed to know everything. Okay, so what's going on here, this was in 2008, magnetic portals connect the Earth to the sun. So back here, and when you look at the magnetic, the plane here, you've got things connecting. Let's see. Right here. This is a picture of our, not the galaxy, not the solar system. And they say that there's the X-ray emissions on the top and the bottom, kind of looking like a p orbital or whatever kind of thing in the theoretical formation of the atom. But I think there's more going on here because there most likely is a toroidal connection between everything. The toroidal electromagnetic situation going on. And the evidence is that every 8 minutes there's a flux transfer event, an FTE, not to be confused with the flux capacitor, Marty. So they were 10 years ago, I was pretty sure they didn't exist, but now the evidence is incontrovertible. So just before the turn of this century, before it became 2000, he was sure that these portals didn't exist. That happens every 8 minutes. But more research has been done that there are primary and secondary flux transfer events. There's the same quote there. But we used to think it was a permanent and that solar winds could trickle into the near-Earth environment anytime the wind was active We were wrong. The connections are not steady at all. They're often brief, bursty, and very dynamic. So there's a lot of interesting things about how the Earth and the Sun are connected, but it's not just the Earth and the Sun. Okay, you've got a bunch of planets here. They're connected. You've got the galaxy where all of this is connected. And you got the galactic center. Here's a nice, beautiful picture of the galactic center. What's going on there? Of course, some theoreticians say it's a black hole. I don't really agree. I think that it's a light hole. Definitely a powerful condensation of matter, energy, and power. But a black hole, there's more going on than what the mathematics indicate. Mathematics is a language to try to describe reality. And some of it works, some of it's not. Sometimes you write a novel with language and the novel is just fiction. Sometimes that happens with mathematics. Anyway, so this is just some fun articles. Now, something strange is sending radio waves from the center of the galaxy. This is actually last year. So this New Scientist article. Strange radio signals are coming from the direction of the center of the galaxy, and we aren't sure what is emitting them. They're turning on and off seemingly at random. Does that kind of happen like a portal connecting Earth to the sun? Perhaps. Maybe there's something going on there. A source of this radiation has been nicknamed Andy's object after Zhaiteng Wang at the University of Sydney's Australia, who goes by the name Andy. Anyway. The object occasionally flared up for a few weeks, but was dark most of the time. When it lit up in February this year, several months after the initial detection, they pointed some of the most powerful non-radio telescopes we have at it and saw nothing. We looked at every other wavelength we can, all the way from infrared to optical X-rays, and we see nothing. So it doesn't seem to be consistent with any kind of star that we understand. But interesting that that's coming from the center of the galaxy. Now, I just thought that was interesting. There is a lot more to come. Personally, I think there is a lot of transducing taking place, energy transfers from one highly centered energetic object to lower energetic objects. So the center of our galaxy is higher energy level than our sun. But I think that just like what this is going on here, that there very well can be electromagnetic situations transferring energy to objects throughout the galaxy and through the solar system. One thing I didn't really talk about in this animation is that the Earth has a satellite, and the Earth has, besides the satellites going around it, we've got the nice little moon satellite. And that there is a connection between the Earth and the moon, because it's hard to fathom how these little things can be rotating. Oh, there goes my fan. These little things are rotating around the sun, and the Earth is held supposedly just by gravity. No, there's more going on. Where it doesn't even show the moon. But the moon and the Earth are also connected, and I personally believe that there eventually will be discovered similar energy transference to hold the Earth and the moon in its lock and rotation, because it's a beautiful relationship, the Earth between the moon and the sun, perfect alignment, perfect balancing, and space. 93 million miles away, is the sun from the earth, and then you have the moon that's a perfect diameter to block out the sun for a perfect solar eclipse, and then the earth blocking out the moon for a lunar eclipse. The symmetry is amazing. And personally, I don't believe it's coincidence, but that's another story altogether. So, back to that, the sun very well could be a transducer, a substance or device such as piezoelectric crystal, microphone, or photoelectric cell, or a hot flaming ball of something that converts input energy of one form into output energy of another, such as converting it from electromagnetic flux to light and electromagnetic spectrum, radiation, infrared. Anyway, I think that's kind of fun. So I'll put this link in the description so you can see these beautiful pictures. And there's also all these beautiful pictures from the X-ray Chandra project. And some of them are just animations, but they're beautiful. Absolutely gorgeous. So might as well take advantage of them and look at them. And those are some of the individual photographs. Images. Absolutely gorgeous. So that's episode 1. If you have any comments or issues or things you want to cover in this 4.5 billion year situation, let me know, because that's what we're going to cover first. And now, not to disparage anybody that works on something, because the title of this is 4.5 billion lies. And some people are not liars. They're just actually going along, get along. Some people won't be able to actually have a job if they don't go along and get along. There have been plenty of people fired because they say, that doesn't fit in with this evidence. And I'm kind of adamant about the truth, so I'm kind of going to hold to the evidence, and they get axed. So you got to be careful out there, because whoever controls the purse and whoever controls the narrative, they're pushing what's going on. But some people are not lying. They're just inducted into the hall of deception. So, lies is a strong word, but if it's not a truth, the opposite is a lie. So that's what I'm going to say about it, and that's it. So thank you all. Like and subscribe if you'd like to. If you don't like it, hit a thumbs down, subscribe, yell at me, or give me praises, send me money somehow. No, I don't. No, that's all right. This is free. All right, talk to y'all later. Episode 2 coming up.